Last time, we covered how you can use Google Cloud Platform metrics as service level indicators to measure the reliability of your services and set reliability targets using SLOs. But what do you do if you need custom telemetry for your SLIs? Today, I'm going to show you how to use Prometheus and OpenCensus to write custom metrics and define SLIs and SLOs using them. Welcome to Engineering for Reliability with Google Cloud. Imagine a basic web application architecture like this. While we can use the metrics emitted by the load balancer to track things like request counts and response latency, what if our application running on GKE needs to keep track of specific transaction details and write a custom counter for them? What if we want to use this kind of custom telemetry as our SLI for the service? This is where custom metrics come in. Today, I'm going to show you how to use two open source approaches to custom metric telemetry. The first one is Prometheus. Prometheus is an open source systems monitoring and alerting toolkit, originally built at SoundCloud. It has a very active developer and user community and joined the Cloud Native Computing Foundation back in 2016. This is the architecture Prometheus uses to collect metrics. The general idea is that your service needs to expose a dedicated metrics endpoint, which Prometheus will then scrape to collect metric data. That data is stored in a time series database and can be queried through a web UI or an API. We'll link to the full code sample in the show notes, but let's have a look at how to instrument an application written in Node.js to emit counter and histogram metrics. Start by defining the metrics themselves. For each, specify the metric type, its name, and help message that will describe what the metric is capturing. To track latency, use a histogram and call its observe method. To increment counters, call their inc method. Finally, create a dedicated metrics endpoint in your application that Prometheus will use to scrape for metrics. The instrumentation is done. Now, if you go to the /metrics endpoint in your app, you'll see a page that looks like this. The metrics and their values are written out here. Now you need to configure Prometheus itself to scrape this endpoint. You do that by adding some annotations in the deployment spec in your application. Enable scraping and define the port and endpoint where the metrics are available. Next, you need to ingest these metrics into Cloud Monitoring. We'll link the detailed instructions in the show notes, but the basic idea is that you patch your Prometheus server with a collector that will send these metrics to Cloud Monitoring. Once your metrics are available there, you're ready to use them for SLIs and SLOs. Here's an example of how you can use a latency metric written by Prometheus to create a distribution cut SLI and set an SLO target for it. A distribution cut allows you to capture the percentage of values that fall within a specified threshold as defined by range. This SLO expects that 98% of responses complete within 500 milliseconds over a rolling 28-day period. Prometheus is a popular open source monitoring framework, and it's well suited for monitoring applications running in GKE. But what if you don't want to maintain that additional infrastructure? In that case, you can use OpenCensus to write metrics directly using the Cloud Monitoring Exporter. OpenCensus is a single distribution of libraries that collect metrics and distributed traces from your services. Let's have a look at how to instrument your service, configure the Cloud Monitoring Exporter, and use OpenCensus metrics to define SLIs and SLOs. Again, we'll link to the full code samples in the show notes. But let's take a quick look at instrumenting an application written in Node.js to emit counter and histogram metrics. Start by configuring the Cloud Monitoring Exporter. This will send the metrics you captured directly to Cloud Monitoring, where you'll then use them to create SLIs and define SLOs. Next, define a measure for each metric. Measures describe how the data points themselves will be recorded. Create a view for each measure. Views are basically the time series you'll be adding data points to. They also include information about how that data will be aggregated. For our latency histogram, you need to specify your bucket boundaries. It's important to at least make sure that you have buckets that capture requests that are going to fall within and outside of your SLO. However, you'll likely want more than just those to allow you to, for example, measure P99 latency. Finally, record values using the record method. Unlike Prometheus, this is the same for counters and histograms in OpenCensus. You won't need to configure any scraping. The exporter will write the values directly to Cloud Monitoring. You can then use them to define SLOs like this. Here's an example of a distribution cut SLI using the response latency metric written by OpenCensus with an SLO of 98% of responses being completed in under 1,000 milliseconds. Thanks for joining me today. In this episode, we looked at how to instrument your code to write custom metrics with OpenCensus at Prometheus, use them to define service level indicators, and set service level objectives against those. You're now ready to start defining SLIs by using these open source libraries in your own services. In our next episode, we'll look at alerting on our SLOs with error budget burn rates. Don't forget to like and subscribe to never miss out on more engineering for reliability with Google Cloud. See you soon.